We are going to look at a forecasting method called exponential smoothing. What I would ask you to think about in exponential smoothing is to think of it as a blending or a weighting between what was the last demand and the last forecast. So where do you want to put your emphasis? We have this thing here, this little symbol called alpha, and alpha is a number between 0 and 1, or between 0 and 100% might be a way to think about it. And let's say we pick an alpha of 0.3. So I'm going to put some numbers in up here. This is what it's saying. Let's say our alpha is equal to 0.3. And our last demand was 250. And our last forecast was 300. So we came in a little bit under the forecast. So if I've got alpha 0.3 and we plug in the numbers, then we've got 0.3 times 250 plus 1 minus 0.3, or 0.7, times 300. So you can kind of see we're putting 30% of last demand and 70% of the last forecast. So we're clearly putting more of a weighting on the last forecast for whatever reason. Now, what I see often in many, many textbooks and places is they'll say typically alpha is between 0 and 0.3. And in talking to former students and that's kind of the reaction I get from them also. But I honestly don't know what the reality is behind that or not. But if we continue on the math, 30% of 250 is 75, plus 70% of 300 is 210. My brain went dead for a second. And so our forecast is going to be 285 will be our new forecast there. Okay? So that's the math behind it. And as I said, it's like 30% of the last demand and 70% of the last forecast. And so we're doing a blending or a smoothing going on in the conversation. Now, I'm not sure why, but there was another way to look at this formula that does the exact same thing. It's just a little bit of an algebraic manipulation that I'd like to show you. I'll do it in red. And so it says this: the new forecast is equal to the old forecast plus alpha multiplied by, and old forecast is the same as last forecast up above, the last demand minus the last forecast. So let's change old forecast to last forecast to be consistent here. So let's plug in our numbers for a sec here. The new forecast is equal to the old forecast, which was 300, plus alpha 0.3, last demand 250, minus the last forecast of 300. And let's keep doing the math. 300 plus 30% of negative 50, which is equal to 300 plus a negative 15, which is the same as 300 minus 15, or 285. So you do come out with the exact same number. I don't know why the textbooks don't show this one anymore. But if you look at the bottom one, so the story on top for the first one, the story is kind of a blending or a smoothing or a weighting, whichever way you want to call it. The bottom one, if you look at this, last demand minus last forecast, what this is how much did we miss by? And so if we work down to here, we see we missed by 50. We came up 50 short. And so we adjusted by 30% of how much we missed. So if you look at the same formula but in red, the new forecast is equal to the old forecast adjusted by some percentage of how much we missed. And so it ended up being down by 15%. Now we don't have space or time on the screen here, but if we did this for another month and we blew by the forecast and we did better, then we would adjust upwards by 30% of how much we missed on the high side. So the story here feels like this. It feels like a month, can't even write, a month by month adjustment by some percentage of how much you missed last month. Okay? So you have a choice on which way to use. They both work. I would encourage you to use the story that makes sense to you, so it takes the pressure off trying to understand what the formula is. But both ways work. It's just a matter of which story makes more sense for you.